Okay, now we're going to go off of this example again, where we were dealing with the 4 friends in a photograph, and apply it to a little bit different scenario, but kind of the same thing at the same time. It just tweaks it a little bit. So now I want you to think of, you have 6 people, but you only want to take 4 of them. Okay, that's going to change up how we would actually solve that problem. Okay, if I am talking about having 6 people and I want to only take 4 of them, okay, we would say that to find the total number of people for that scenario would be, there are 6 options to choose from first. There would be 5 options to choose in the second spot, 4 options to take in the third spot, and 2 options to take in the fourth spot. Okay? Excuse me, not 2. It would be 3. Excuse me. Okay? So that would be how we would represent choosing 4 people to be in the photograph. 6 times 5 times 4 times 3. That would get you a value. I would need to do that quick myself. 6 times 5 times 4 times 3 gets me a value of 360. So there would be 360 different ways to choose from 6 people and just wanting 2 of them. Okay? Another way that we can represent that is using a button on your calculator at the same time, which looks something like this. Okay, this P means I'm talking about permutations. N would be the total number of people. R is how many I'm taking. So in this case, if I was saying I have 6 friends and I'm choosing 4 of them, I would say 6 P, and then I'm taking 4 of them. You can plug that into your calculator and it would get you 360 as well. I'll show you where that's located in your calculator. So coming over, turn mine on. I have 6 friends. I'm going to go back to math, and under the probability section where I found my factorial, NPR is the button that you would want. Press enter, and then say I'm choosing 4 of them, would get me 360 people. Okay, and really what it's stating, if you want to know when you're plugging this 6 NPR thing into your calculator, what is that really calculating? It's saying I have 6 people, so 6 factorial, but I'm only choosing 4 of them. And if you plug that into your calculator, you'd also get 360. By far my favorite way of understanding it would be this top one. That's probably the method that I'm going to use. Okay, so let's do an example that uses this scenario. Oops, got to get rid of this. So a class is divided into teams, each made of 15 students. Each team is directed to select team members to be officers. If Sam, Valencia, and Deshane are on a team and the positions are decided at random, what is the probability that they are selected as president, vice president, and secretary, respectively? So I'm still dealing with probability, meaning I need total possibilities and what I want out of this. Okay, so for total, a class is divided into teams, each made of 15 students. So there are going to be 15 students total in each team. Each team is directed to select team members to be officers, and those officers are president, vice president, and secretary. Well, of those 15 students, only 3 of them can be officers, can be either president, vice president, or secretary. So that means the first person that they choose, they have 15 people to choose to be president. They would have 14 people to choose from to be vice president. And then finally, they would have 13 people to choose to be secretary. Or you could say, I have 15 students, and I'm choosing 3 of them, if you want to use that into your calculator. So 15 times 14 times 13 would get you 2,730 choices. Now they're talking about specific people. Sam, Valencia, and Deshane. They want Sam to be president, Valencia to be vice president, and Deshane to be secretary. How many ways can I make those exact three people be in those exact positions? There's only one way to do that. So we would say that our probability would be 1 over 2,730.